everyone, in today's video I'm going to be talking about like terms. So what are like terms? Well, like terms are terms that contain exactly the same combination of pronumerals and indices, or other words, powers. So you would have remembered from my last video that a term in algebra is basically just every part that makes up an expression or an equation, okay? Now, only like terms can be added, subtracted, multiplied, or divided, etc., okay? I will run through some examples on how to identify whether certain terms are like terms or not. So here I've just got 3 examples. The first one, 6BC and 3BC are like terms. Okay, yes, that is true. 6BC and 3BC are like terms because the pronumerals, which is just a mathematical word for letters, all right, are exactly the same. When we look for like terms, we do not care about the number that's out in front of everything. The number out in front does not determine whether something is a like term or not. Okay, so the number out in front does not mean that 2 terms will be like terms or not, because it has nothing to do with it. What you are interested in to identify 2, 3, 4, however many terms as like terms are the letters, okay? Now, these are like terms because in this term over here, we have a B and a C, and in this one over here, we also have a B and a C. So because these pronumerals are exactly the same as each other, just the parts that I've underlined, that means that these 2 terms are like terms, okay? So let's go down to example number 2. 10A and 5AB are not like terms, okay? And that's true. They're not like terms because here in this term, we just have an A. Whereas over here, we have an A and a B together. Now, here in this term, the first one, there's only an A by itself. Whereas over here, there's an A, yes, but a B is stuck to it, okay? These 2 are not the same. An A is not the same as an A and a B. So even though there is an A in here, yes, it is not exactly the same as this part over here, which is just an A. Now again, we do not care about the numbers out in front. The numbers out in front can be whatever they want to be. You need to know that in order to identify like terms, the pronumerals need to be exactly the same. And these 2 are not exactly the same because this has just an A and this has an A and a B. Okay, so they're not like terms. Now let's have a look at some powers, okay? 2x squared and 20x squared are like terms. That's true because look, we have an x squared over here and an x squared over here. These 2 are exactly the same. X squared here, x squared there. Because they're exactly the same, we say that these 2 terms, so everything all together, are like terms, okay? But 2x squared and 20x cubed are not like terms. Why? Because here, in this term, we have an x squared. But in this one, we have an x cubed. So this one has an x to the power of 2. This one has an x to the power of 3. Yes, they both have an x in them, but this is to the power of 2, this is to the power of 3. So they are not the same pronumerals to the same power. They're different. This is to a 2, this is to a 3, which makes them different, and hence the overall terms are not like terms. Okay, so you just need to remember, in just simple terms, the letters and whatever they're to the power of need to be exactly the same in order for 2, 3, 4, however many terms to be considered as like terms. We don't care about the numbers out in front. Okay? So let's practice with some examples, but before I do so, I'll just leave the page like this. You can pause and write down these notes in your book. Okay. So question 1. Now these questions, question 1 relates to section 1 from the learning activity, and question 2 below relates to section 4. Okay, so question 1. Answer true or false to each statement. Okay. 6Z and 9Z are like terms. Well, let's have a look at the letters or the pronumerals. We have 1Z here and 1Z there. So because these two letters or pronumerals are exactly the same, then 6Z and 9Z are like terms. So that's true. Okay, so 6Z and 9Z are like terms because the Z's in them are both exactly the same. 7A and 7B are like terms. Now, yes, the coefficient, which is the number out in front, is 7 in both of these terms. So we've got a 7 here, 7 here. But remember, we do not care about the number that's out in front. We care about the pronumeral. And here we have an A, whereas here we have a B. Now, A and B, they're both different, meaning that 7A and 7B are not like terms. So that one is false. Okay. Next one, negative 3K and K. Okay, so when we have a letter or a pronumeral that is by itself, no number out in front, there is an imaginary 1. So I can go ahead and just write 1K over here. Now, let's have a look for the letters. There's a K over here and a K over here. So because these pronumerals are exactly the same, the negative 3K and 1K are like terms. So it's true. Doesn't matter that this is a negative. It doesn't matter that this is a positive. Like I said before, we do not care about the numbers. Okay? We care about the letters or the pronumerals. Okay? D, 9xy and 10x squared y are like terms. Well, here we've got an xy. And here we've got an x squared, so to the power of 2, y. Okay? Yes, technically we've got x and y's in both parts, but this x over here is just x by itself. This x over here is an x squared because this is x and this is x squared. They are not like terms. They need to be exactly the same and to the exact same power. The numbers out in front don't matter, but the numbers as powers on top of a pronumeral do matter. And because this x has a 2 in it and this x doesn't, they're not like terms. So yes, the y's are exactly the same, but here we've got an x squared and here we have just x. So overall, this and this are not like terms, so that would be false. Next one, 5ABC and 14ACB. All right, well, here in our first term, we've got ABC as our pronumerals. And here in our second term, we've got ACB. Now, you'll notice that ACB is just ABC, but the pronumerals are written down in a different order. So that doesn't matter, okay? Doesn't matter what order the letters or the pronumerals are written in. As long as they are exactly the same as what is in every other term, then the two overall terms are considered like terms. So this has an ABC. This one also has an ABC. It's just written slightly the other way. The C is second here, but the C is last here. Doesn't matter, okay? Because at the end of the day, we still have an ABC here and an ABC there. So these are like terms. Okay, last one, 19D squared and 21D cubed are like terms. Well, I said to you that the number out in front doesn't matter, but the number as a power does matter. Here we've got a D, but to the power of 2. And here we have a D, but to the power of 3. Now these numbers are not the same. So that means that these are not like terms. So it's false. Okay? For these two terms to be considered like terms, this would have had to be a D squared to match this, or this could have been a D cubed to match this. Okay, but they're not, they're different. So they're not like terms. Okay, so again, I'll just leave my page like this so you can pause and write down the answers, and we'll move on to question 2. Okay, question 2. Simplify each expression. Remember, expressions don't have equal signs, by collecting like terms. Okay, so let's try the first. Now I'm going to use different coloured pens to make this easier. You can also feel free to do so. If it makes sense though, you don't have to. Right, so in order for us to simplify any expression, we can only do so if we collect, all right? So if we grab like terms, all right? So you'll see here in question A, this one is quite easy actually, because every single pronumeral in every single part of this expression, so every single term, is an F. F there, F there, there. All right, they're all Fs. So they're all exactly the same. We can collect all of these terms as like terms because there are Fs on the end of every single number. Okay, so all we need to do is now take those numbers in front of the Fs, add them all together. So we would take the 4 and do 4 plus, then take the 9, plus, then take the other 9, plus, take the 2, plus, and then the last 9, plus. Okay, so we will take all of these numbers together, all right, add them all up, only because each pronumeral in each part of this expression are all Fs. So we would group all of them together to get an answer. Okay, so add it all up and you should get 33. Okay, so all the numbers added together are 33. but you need to put an F at the end. So the answer is 33F, okay? So you take all the numbers, because these are all like terms, add them all up to get 33. So your answer will be 33 with the F on the end, because they all have Fs. Okay? Another way of visualizing this is like this. Well, here we have 4 Fs. So imagine 1, 2, 3, 4. Then we have 9 Fs. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we have another 9 Fs. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we have 2 of them. 1, 2. Then we have 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. This question just means this. And if we went ahead and counted all of these Fs, we would get 33 of them. So the answer would be 33 Fs. Hence, how we get this as our answer. Okay, let's try the second. This one's a little bit harder. We need to find our like terms. Okay, so here I can see that I've got a Y. I am going to underline every single term here that has a Y to it. And I'm going to use my orange pen. So, the first one. This has no Y to it, so that's no good. This does. Take this sign with it too. This doesn't have a Y, so no. This does have a Y, so yes. And this also has a Y, so yes. Now, let's go in with a different coloured pen and underline all the normal numbers, so the constants. Well, this is just a number by itself, so it's in blue. And this is also a number by itself, so that can go in blue too. Okay, so I'm only allowed to simplify the oranges with each other and the blues with each other. And they need to be done separately, because everything that's underlined in orange is a like term. Everything that's underlined in blue is also a like term, but a different like term. Okay, so I'm not allowed to mix oranges with blues. Oranges need to stay together, blues need to stay together. So let's do the oranges first. 6Y minus 2Y, so I shouldn't have written that. Next orange, plus 7Y minus 2Y. So now I just take all the numbers out in front like I did here and add and subtract them. Now what you can do if you're a little bit rusty on your negative numbers, you can just put them in your calculator as you see it. So we've got a 6 minus 2 plus 7 minus 2. Okay, and you see that you get 9. So all of this together equals 9Y. So I'll just write it down here. Okay, now that's not my final answer because I also need to do the blues. I'll do the blues next to it. So we've got plus 6. And the next blue, minus 5. Okay, and 6 minus 5 is just 1. So we would write, you can't just write a 1 like that next to it. Okay, this is technically 1, which is plus 1. So you'd have to write plus 1. You can't just leave the 1 just lingering there by itself. 1 as an answer is like +1 or +1. So you'd write +1. And that's my overall answer. 9y plus 1. Okay. Next example. Let's go again with our different coloured pens. Right, here we've got an X by itself. So let's use purple to underline every single X that's by itself. Take the sign with it. There's 1. No X by itself, so no. X by itself, so yes. No. Or we've got an X there, but it's with a Y. So that's a no, because there's no X by itself. And this one is also a no. Okay, next colour. Let's go pink. Let's underline all the Y's by themselves. So we've got 1 here. No. Yes. There's a Y there, but it's not a Y by itself. So that's a no. And there's no Y there, so that's a no. Now let's take our next colour, which can be green again. Let's take all the XYs. Well, there's only one with an X and a Y together. And then lucky last, we'll go with blue again. Numbers by themselves. Now we are only allowed to deal with each colour separately because each colour relates to a different like term. So let's start with the purples, the X's. What do we get? We get -3x. Next one, plus 4x. And there are no more. So what do we get as this answer? -3 plus 4. Well, that equals 1. So it's 1x. Now let's go to the next colour. Next one is purple. So we've got plus 6y. Next, pink. Sorry, I think I just said purple. Pink, I meant. Next, pink. This one over here, -9y. And that is all for pinks. So now let's do the pinks together. We have 6 minus 9. All right, what's 6 minus 9? It's -3. So we'll add -3 and then the y to our overall answer. Our next colour is green. Well, there's just one of those, so that's easy. It stays as it is. So we can carry it down to our answer. And then we've got blue, again easy because it's the only one we've got. So we can carry it down to our answer. Okay, so this is our overall answer. Now, you don't actually need to write the 1 in front of the X. Okay, you can leave it like so. Just to tidy it up, and I'll rewrite the answer in blue. X -3y plus 5xy minus 2. Okay. Last question. So we have some powers here. We'll use orange for the first colour. We're trying to find the x to the power of 2's. So I'm going to highlight this as orange. X to the power of 2, yes. X to the power of 3, no. No x at all, no. 1x by itself, no. 1x by itself, no. So we've got 10x squared plus 2x squared. What is 10 plus 2? Well, it's 12. So that gives me an answer of 12x squared. Next colour, let's take our purple and we'll underline our x to the power of 3's. So there's 1, no x at all, so no, not to the power of 3, so no, not to the power of 3, so no. So we've only got 1. So that makes it super easy because we can just carry it down to our answer. We'll use pink for the next one. So numbers by themselves. Okay. Is this a number by itself? No. Is this a number by itself? No. So again, easy. We can just carry it down. Okay. Okay. And then lucky last, we'll pick another colour. So I'll go with light blue. And I'm getting my X's by themselves. There's 1 and there's another one because X by itself. So we'll underline that. Remember, when there's no number out in front of the X, it just means imaginary 1. So that becomes plus 1x plus 5x. 1 plus 5 is 6. So it's plus 6x. So my overall answer will be this. Okay, so again, I'll just leave my page like this. So you can pause and copy this out in your books. Apologies for the colours. It might not be that easy to read, but you can copy it down in your books however you like.